Hi everyone, our job today is to learn how to find the greatest common factor of two numbers. So let's define it first of all. The greatest common factor of two numbers is the largest or biggest or greatest number that will divide evenly, meaning no leftovers or decimal parts, into both numbers. Well, here we've got the factors of 12. Start at 1 and work our way up until we list all the factors of 12. 1, 2, 3, 4, 6, and 12. Because 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Those are all the factors of 12. And then the factors of 16. 1 and 16, 2 and 8, and then 4, because 4 times 4 is 16. So as we look at these two lists, we see that 1 is common to both, 2 is common to both, and 4 is common to both. 1 is always going to work, right? So we kind of disregard 1 when we're thinking about factors. 2 you see there, and that is a common factor, but if you'll notice 4 is the biggest or the greatest common factor. So 4 is the greatest common factor for the numbers 12 and 16. All right, I'm going to show you an example about how to find greatest common factor before I actually fill in the steps. I think the steps will make more sense to you after you've seen an example. So we're looking for the biggest number that will divide into both 36 and 54. So I'm going to write my two numbers down side by side. Then I'm going to make what we'll call a ladder rung. All right, that kind of looks like a step on a ladder. We're going to start with our prime numbers, 2, 3, 5, 7, 11, and see if we can divide these by those prime numbers. Well, I noticed that they're both even, so they can both divide by 2. 2 divides into 36 18 times, and 2 divides into 54 27 times. So I'm going to check and see if I can divide 18 and 27 also by another number. I can't divide both of them by 2. 18's even, but 27's not, so that won't work. But 3, my next prime number, divides into both of those. And so 3 divides into 18 6 times, and then 3 divides into 27 9 times. Checking again. 2 works for 6, but not for 9. But 3 works for both of these. And so I'm going to divide both of these again by 3. 3 divides into 6 2 times. 3 divides into 9 3 times. Both of these numbers are prime, so I know that nothing will divide into them other than 1. To find my greatest common factor, then, I'm going to take the 3 numbers, or 2 numbers, or however many numbers are here. It could be 4, but in this case it's 3 numbers along the side. And I'm going to multiply those numbers together. And the product of these numbers is the biggest number that will divide into both 36 and 54 evenly. So 2 times 3 is 6, 6 times 3 is 18. So we're saying that 18 is the biggest number that divides into both 36 and 54. Okay, so now I think the steps will make more sense to you. Let's fill those in. We're going to write the two numbers next to each other. So you're going to put next in that first space. Draw one rung of the ladder under both numbers. Find, I'm going to say the smallest prime number, because that's easiest. Smallest prime number that will divide into both of the numbers. And start with 2, 3, 5, 7, 11. You'll probably find it there. All right. Keep adding ladder rungs and dividing until the numbers have no other common factors, so no more common factors that will divide in evenly. Then multiply the numbers along the side of the ladder. All right, and there you go. That's how to find greatest common factor. All right, let's look at another example here. So remember, write the two numbers down next to each other. Make a ladder rung. Start with your prime numbers. My lowest number is 2, and that can divide into both of these. 2 divides into 40 20 times. 2 divides into 24 12 times. Add another ladder rung, because I can divide both of these by 2 again. 2 divides into 20 10 times. 2 divides into 12 6 times. Check again. Can I divide 10 and 6 by one of the prime numbers? I can. I can divide both of those by 2. They're both even. 2 divides into 10 5 times. 2 divides into 6 3 times. These numbers are both prime. They don't have any common factors other than 1, so we know we're done. So we're going to take the numbers along the side. And again, they won't always be 3 numbers. In both of our examples so far they have been. But this will be 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So we're saying that 8 is the biggest number that will divide into both 4 and 24. All right, I'm going to skip the 65 and 120 for right now. Go down here to a situation where finding greatest common factor can be a practical skill. This says you are making treat bags for a party. You have 24 Smarties and 36 chocolate bars. What is the greatest number of treat bags you can make? Well, we're going to take 20. Notice the word greatest here. That's our cue that we're looking for the biggest number that will divide into both of these. So 24 and 36. Smallest prime that will divide into both of those is 2 because they're both even. 24 divided by 2 is 12. 36 divided by 2 is 18. We can divide both of those by 2 again. 12 divided by 2 is 6. 18 divided by 2 is 9. We can divide both of those by 3. So 3 divides into 6 2 times, and 3 divides into 9 3 times. These are both prime, so we can't divide those up anymore. We're going to take 2 times 2, which is 4, times 3, which is 12. So the biggest number of treat bags that we can make is 12, so that we have the same number of Smarties and chocolate bars in each one. All right, guys, that's how to find greatest common factor. You hear our bell, so I've got to go now. Thanks.